Professor Borg with his collaborator. I mean, my director and the other top manager today are lucky for us. They were out of the office, and I know that there were some deadlines, some constraints, let's say, regarding this meeting. So we had the meeting. Although today, to be honest with you, at the moment we are suffering a bit directive. There are many things ongoing, but we usually don't stop. We do things just the same. In fact, today we are here with you and Dr. Barilaro to discuss about that. I'm very happy to see this collaboration. I'm honored to see my department this such of research, because before this was never the case, I can assure you. I'm glad as well to see the student here, because although they're very young, in Mobile it's very important to cross-fertilize this kind of knowledge, because that's the way that you make born the idea to have research. Because if you people they believe that the job is only produce or design, it's wrong. Everything starts from research. If you don't have research, today we were not here. And we don't see these things. I mean, it started with Professor Borg, started this project at the university. He actually sort of taught us to go on our leg, and now today we have our small project with Dr. Barilaro. But as you can see, there is a sort of someone which is skilled, releasing knowledge to someone that's younger, and start to grow. That I think is well for Professor satisfaction, because today you can say that it starts with us, and today you can see that MCAST is doing something as well. So it's the pass for the knowledge is important. It's not to have the knowledge, because I can have how much knowledge I have. If I keep the knowledge for me, it will not be really knowledge. It will be something that will be lost with me. I think all of you inside has these things to research, and then do this to immediately to give this knowledge to someone else, so that someone else can grow and can naturally make better than you. Because at the end, success is not a limited resource. Success is it's a big mistake when people think that if I'm successful, my colleague cannot be successful. There is no any limitation in successful. You have a friend, and only your friend can be very successful. It's not a limited resource. There's no any constraint on it. All of us in this room can be successful. There is no someone which limited how many people can be successful. So you don't need to be in competition. You need to cooperate. You need to try to share as much as you can. That's the way that will make you grow. That's the only person. Your personal growth is depending even from that. When you start to understand that sharing is more important than keeping, then you really become a person with a value. So I'm very blessed to start this small meeting, but I pass immediately the word to our SRO, Francis, which will explain how the research start to work here in Malta. Because at the end in MCAST we didn't have let's say an institute of research like a university, which is more established. We are starting now, so we are not super experienced like the university, but we start with the goodwill, with the good wish to become good. I mean, why not? One day we would like to be a good partner of the University of Malta as well. Why not?
Thank you, Roberto. Hello, everyone. Thank you for joining us. So I'm Francis Delicata. I form part of the Applied Research and Innovation Center here at campus. We're relatively a small team so far, because we have been established only for a few years. My director sends her apologies for not being able to join today. So I will be brief. It has been a pleasure supporting Leonardo this past. I joined MCAST only a year ago, so I've known Leonardo for just 1 year. But it's nice to see someone with such drive and passion for research. At MCAST we need more people like Dr. Barilaro in order to get research going and to acquire funds. It's the space sector which Leonardo is working on is relatively new to Malta. To the best of my knowledge, we're still, we're competing with many huge international companies and international researchers, so it's quite a difficult field to break into. And it's very exciting to see that Leonardo has had very successful few years in acquiring funds and in setting up and implementing projects here at MCAST successfully. And I think that's it for now. I'll leave it to Leonardo. Thank you everyone for joining.
Thank you.
Hello, everybody. Thank you, Roberto. Thank you, Francis. Just a short introduction to give you the background. So today we are honored to have here Professor Joseph Borg and two members of his team that I will introduce shortly after. I just want to do this introduction for the future. So most of you are young here. Just we will discuss later on. So most of you are young here. Just to let you know, Joseph opened a new era for Malta because yes, there were some activities space related, but when I arrived in Malta, basically there was nothing. And now these are the first years where we are really doing something. So Maleth program was the first program that put something in space, which is amazing. And now we are building up here at MCAST with the ASTROBEAT project. So also one thing that is less technical is that no one tells you how much work goes behind the scene. It's grueling, it's a lot of short hours. You have to be be resilient because one thing is working in countries where the structure is established. And another thing is when you are doing something for the very first time. So prosit to Joseph. Plus, I will speak later about this. He also opened something totally new here in Malta. And when we started our collaboration for Maleth 2, originally I took part only with my music because, as you know, I'm also a pianist, and the music went to space. And after that was Maleth 3, and now ASTROBEAT. So thank you, Joseph. Now, floor is yours.
So do we use this as well?
Yes, and let me open the...
Okay. So good morning, everyone. And it's a pleasure to be with you here this morning as well. So last I was here was during a meeting with yourself, with Roberto, and maybe other people from the board. That we also spoke about the missions and the events that we can do together jointly in space. So yeah, so we will talk about Maleth program, but perhaps the slide should, yes. So Maleth started in late 2020, early 2021. So Maleth consists of 3 missions that we sent to the ISS. And I will explain to you very, very briefly what it is, what we did, and what is the importance behind the science, the medical and health implications of this mission, but also how does it reverberate with computer science, with engineering and technical skills as well, which I think would be of interest to all of the people attending this morning's event. So yeah, so the idea was conceived in 2020. So if you recall, during those times was the COVID years and pandemic years. So I was spending a bit more time reading than in the lab as well. And at the time, I was thinking about the research, the life science research that we do at university, but how can we make use of additional tools, additional laboratories? And the use of the space station, the ISS, is indeed a glorified, a huge laboratory. It is as big as a football stadium, so it's huge. And it is equipped with various items of equipment. The idea that there is almost 0G or microgravity, the fact that there's a lot of radiation as well. So in the context of life science research and the cells of interest, cell models, humans and the astronauts themselves, we will talk about that later on as well. But space serves as a very good medium, as a good model to study life, how it adapts, how it reacts, how it changes in space. And of course, we can study the genetics, the blood, the DNA profiling before the experiments are sent to space. Sometimes we can study the genetics in space as well. And of course, we can study the genetics when the experiments come down back to Earth. So by 2020, the idea was conceived. The first pilot studies and the first launch, which is Maleth 1, which is this cube here. So you can move it around next to each other. So my colleagues know about this, but you can feel free to open let's open the cube, and you can see the internals of the cube. So what you are holding right now is the first cube that went to the ISS from Malta. That's Maleth 1. And that experiment, of course, as you can see, it's like split in two. One half is a computer science and electronics experiment. It has a Raspberry Pi module. Maybe it's Arduino, I always forget. Raspberry Pi. And the other half, which is this half, is dedicated for sample acquisition and biological samples. Of course, there are no biological samples right now, but that's when things are integrated in a space engineering laboratory. You can see two cameras there as well, LED lights. And the beauty of that, and then maybe during discussion, Gordon will talk about that as well, is that that cube, once in space and connected in the space station, we can communicate with the cube. We can write commands, script commands, we can execute commands, and we can download and upload various files, folders, so on and so forth. So there is a direct communication, a direct link between our labs and the space station, basically. So that's the first mission. And then there was a second mission in 2022, and finally the mission last year that ourselves, but rather than just university, also Spaceomix, which I will mention this in the next few slides, is an idea that myself and Gordon here, we thought about, because instead of just looking at just the research part, having a biotech, having part of the industry out there, which doesn't only have R&D as its only idea, but there is also commercial, private interests, and how this can be exploited to the public out there as well, in the context of economy and industry. Okay? So things must not remain only within an academic or research setting, but should also be pushed out there into the economy as well. That is our idea. And I think slowly, it's very slow, but it's very sure as well. So I'm very excited for the future that we are in right now. Yeah, so this is the slide. So what is it all about? I think I should give you some small background. So the science inside Maleth is biological sciences. So a PhD student at the university is looking at diabetic patients, diabetes type 2. You've heard of diabetes, right? And in Malta, it's one of the highest rates of diabetes in Europe. So we are 9th overall. And as a complication of diabetes, some patients develop ulcers or foot ulcers. So these are wounds at the bottom of their feet. And unfortunately, they become infected, bacteria, microorganisms. Okay? And when infected, a number of these patients cannot get them treated with antibiotics or medicines because the bacteria are resistant. They are drug resistant or antibiotic resistant. So unfortunately, these patients have to have their toes amputated, the foot amputated, or below the knee amputation. Now, in Malta, there are more than 400 patients or people undergoing amputations in 1 year, 400 and more a year, which is a very high rate. Okay, so it's important to talk about this and make people aware of these complications. So Christine Gatt, who's a PhD student, she's looking at hundreds of patients from Malta. But from these hundreds of patients, we also selected those patients with a very, very difficult and hard to treat infection. And we took what is known as a microbiome. So microbiome is the collection of bacteria located in one place. So there are oral microbiome, so the microbiome in your mouth, the gut microbiome found in the intestines, and there are skin microbiomes. So when you put your hands and shave off like this, you have tens or 20s of different bacteria roaming around. And the foot ulcer is no exception. So the foot ulcer, there are many bacteria which everyone has on the skin, but these people have opportunistic bacteria, some of which found on the skin, but they infect the ulcer. And some of them might be also a complication because of hospital or community acquired or because of the wound itself. So the idea was that because these bacteria are so difficult to treat, so difficult to handle, we wanted to study them on Earth, as we normally do, but we also wanted to see their adaptation, their reaction in space. Okay? So we see how the same type of bacteria, how they compare, how they differ from space to Earth. and whether there are important genetic signatures or genetic, how do you say, labels that we are able to capitalize upon for treatment purposes, okay? Okay. Let's see. Why is not moving? Maybe I should do this. Okay. Yeah, so this is a very small type of foot ulcer. Usually they're also much larger, okay, and much worse than this. Yeah, so this is the actual cube that you're holding yourself. So you can see the full assembly of the internals directly. Something small, a small parenthesis. So besides all the research and all the, in inverted commas, serious stuff that we do at university and at Spaceomix, but there is also a part which is STEM, right? So science, technology, engineering, and mathematics, also art. So sometimes we say STEAM instead of STEM. And what we did in Maleth is that we engaged the young students at schools. So we told them if they had an idea, a message that they want to send to space. Of course, they were all smiling and laughing. They couldn't really understand what. But we told them, give us an image, a picture, write something, anything that you want, which is decent, of course. So anything that has to do with climate change or bullying or whatever comes to their mind. And we told them that their message will be embedded inside the digital card in the cube. And this cube, of course, will be sent to the space station. So with Gordon and team and the Spaceomix, so we could enter the electronics, we could enter the operating system of the cube, and we can project or downlink or stream down from the cube, from space, down to Earth using social media like Facebook, LinkedIn, or Twitter. Now it's called X. So we could do that. So we could show the message that these children wanted to convey from space down to Earth. And I think that it is an interesting way how to go down to the level of young kids at primary and secondary schools. And also we had our colleagues from the States visiting us here in Malta to showcase these events, like Jim Green, who's a former chief scientist at NASA. Okay, some more work. Yeah, so this is some more work done in the lab in Belgium. It's a bit choppy. But what you're seeing here is what also Dr. Barilaro did together with my colleagues back in space applications in Belgium. I will show you a few pictures of that as well. So it's not because here in Malta we don't have engineering labs or space engineering labs, because we have. But of course, for a moment, we still lack the expertise, okay, to fully assemble a cube, a biocube, possibly a CubeSat in the near future, and how this is done to the correct specs that are required by ESA or by NASA, okay? Because there are a number of tick boxes that one has to follow, one has to honor, and once all of those are ticked, then that cube, that mission can go to Cape Canaveral to be placed inside a SpaceX rocket or other in preparation for launch. So there's a lot and rigorous, how do you say, vetting and reviewing that is done before these cubes are sent to launch. Oops, okay. So this is a setup. Okay, so this is the setup that we have together with Gordon and team, okay? So we don't have a mission control room like NASA has or ESA has, so it's much smaller, much humbler. And of course, we don't need to worry about controlling the whole space station because we are interested in our cube only. So that is why, how do you say, it is proportionate, right? It's proportionate. The scale. So this is our mini mission ground control, and the number of people also that work at the company at the time, also Arcafort, but also undergoing changes that we find ourselves today as Spaceomix. Yeah, so this, I don't need to tell you too much about this. So this is how would a typical SpaceX launch would appear from the States. Yeah, and this was the first cube that was in space and handled by the French astronaut Thomas Pesquet. Okay. It seems that the space interval is catching up with him as well. Yeah, so basically here Thomas Pesquet is talking with ground control about handling of the cube. I'm not sure if I can increase a bit the volume. Let's see. Maybe. Yeah, that's okay. Ah, here. It's okay. So this was interesting because at that time, it was the first time that he mentioned these cubes from Malta and other players. So it was very, very, how do you say, a proud moment for all of us here. So this would be the cube that you're holding, sitting alongside other cubes, and this facility here, this is actually inside the space station. So this is called the ICE Cubes facility. ICE stands for International Commercial Experiment. Okay, so that is where the name implies, and this is where the idea comes also for the private and the commercial part is also of interest, because these experiments, these facilities need to be maintained not just by research, but they need to be funded, okay? And there has to be a business case involved as well. Okay. So, okay, fast forward. So this was the first mission. This was the second mission handled by Italian astronaut Samantha Cristoforetti. So we had other local funders, Me Direct Bank, Singleron is a German company, and some other companies in Malta. And here this third mission, but you will see a video later on, is handled by Sultan Al Nayadi from the United Arab Emirates. And that is where MCAST and the MG2I were also involved. So this unfortunately is still sealed, so we cannot open it here, but you can also take a look at the cube itself that bears the MCAST and the MG2I logo. So this is, so what is interesting is that the first cube, okay, that you are handling, that is the first mission 2021. We did that once, we sent it to space once and came back. This cube, okay, so this is machined aluminum, so you can see it is not 3D printed, so it's a different make. And it also flew twice to space. So this cube is part of, how do you say, we try to build on the promise of renewability or you know, trying to be friendly to the environment. So you can also hand over this to your colleagues. So you are handling space heritage and space artifacts in this room right here. And if you are curious about the internals of the cube, it looks something like this. So it's essentially the same that you're seeing in Maleth 1, albeit a few, how do you say, modified wires and changes. So these are the cubes in place, and the electronics are all here as well. And Leonardo Barilaro took active part in the assembly, and he was present in Belgium to be part of the whole process, if you like, from an empty cube without samples to the integration of the samples, and also doing the quality checks and confirmatory tests, and how this cube is now certified for space. And this video I'm showing you is of the handling of the astronaut, and also showing MCAST's, let's see, MCAST's role as well.
Skin tissue samples of patients from both Malta and Saudi Arabia population are integrated in this experiment here in the ICU facility in the This experiment is led by biomedical scientists at the University of Malta in collaboration with scientists from King Faisal Specialist Hospital and Research Center in Saudi Arabia, World College of Medicine in the USA, and the Mohammed Faraji Space Center in the UAE, who will all benefit from the resulting data and share it with the world. This experiment is just the beginning of what we can achieve together through international collaboration. And as a UA astronaut, I'm happy to contribute, and I'm confident that the result of this project will inspire future generations to
Okay. Okay. And that's where this logo also appeared alongside. I mean, you can also see something else here, right? So this is not a solitary or a single institution, but multiple institutions, multiple entities, which come together in a supportive and a collaborative manner. I think, truth be told, this is the way how to make meaningful research. Okay, so I will try not to take too much time also for Leonardo's next talk. So when the cubes, Maleth 1, Maleth 2, including Maleth 3, okay, when these cubes go to space, they stay there for 35 days, then brought back. Once brought back, so we couldn't have come with the cube to MCAST directly because inside it is a biological experiment. So we needed that experiment to go to our hospital labs, to our pathology labs. We open the cube and we conduct our experiments in the labs. So basically, we obtain from the skin tissue the bacteria, the microbiome, and we see the microbiome, how it differs in Earth from space, and it is a comparative genomics, basically. Okay? So to do that, we make use of systems and machines that we have in our labs. Basically, these are machines that read DNA, essentially. And instead of reading bits and pieces of DNA, they read a full profile of DNA. And not just of one bacteria, but all the bacteria, hence microbiome, present in a cell. And you get a breakdown of all the different bacteria found in a given sample. So a very simple assessment or statistic is to see any differences or change in the percentages of the types of bacteria found in space and in Earth. Okay? Remember that the sample is exactly the same, so the starting point should always be the same. Okay? And then we see the differences when landing back on Earth. In fact, we did all this. I will skip much of the technical details. So we did observe genetic differences in certain groups of bacteria. So these are bacteria names, okay, or different species, okay? And what I can tell you in summary is that some bacteria that are found here on Earth immediately die off when in space. A modest number remains largely the same. And a small group of bacteria, when in space, they flourished much more, they grew more. So it's like it was conducive for them to grow further. So those are very interesting observation. And we have documented all this in a publication that we published in Cell Press Helion. So this is a freely available publication that anyone can read. And finally, you can see your very own Leonardo representing MCAST and MG2I as well, I believe, with all the group in space applications in Belgium. And this is the cube that you're handling right now. So this brings to a one full circle all that is Maleth. A few other slides. So yeah, so maybe just to conclude. So the data, most of the academic data that we generate is freely available. We share this, it's publicly, it's open shared, and together here with Anu as well. So we form part of NASA's Gene Lab. So NASA's Gene Lab is a group of people across the world, across the globe, and we work on experiments that we send to space and back. And the data that we generate, we make it available on a repository, on a portal. So it's of course available to us and our colleagues, but also to anyone else who wants to inquire, to look at this data and do their own research as well. So we are very, very proactive in this as well. Yeah, so besides all things Maleth, there are other things ongoing. You will hear about this in the months to come. So we also have relationships ongoing with private astronauts, especially flying on SpaceX missions, where we continue looking at not the microbiome, not bacteria, but looking physically at their blood status, at their anemia. Okay? We take blood before they launch to space. They take their own blood when they are in space. And we also take their blood when they land back to Earth. So this is a lot of active area and progress. And finally, yeah, that's the Polaris Dawn. These are some tests that we do. So this might be a bit too much to talk in this event in the morning here. And I want to conclude with this. So as Spaceomix, we also have ambitions that set beyond just the ISS. I mean the ISS As you've seen, we've sent once, twice, we've sent a third one. MCAST are also there as well. I mean, the ISS is within reach. So with a good plan, a good design, everything starts with design of experiment. Funding here and there can be applied for, can be through competition. So besides the ISS, now there are additional experiments that we would like, or we are set out to do. And as Spaceomix, which we are representing as a space biotech company here in Malta, and we also assisted MCAST to be present on board the ISS, but we are also looking at additional experiments that we would like to send to the lunar surface and beyond in the next couple of years. So I can tell you that it is a very, very exciting time to be living, to be working together, and I hope to see many experiments coming from Leonardo and his team from MCAST as well. I finish off here, so I thank you for listening. Good, thank you.
Thank you, Joseph, for the beautiful presentation. So, today I will provide an overview, not too technical, but fun fact, they are students from aviation, so it's their bread regarding the topic that I will discuss today. So I will provide a bit of background history, building up on what Joseph said, and I will describe a bit more in detail ASTROBEAT, which is the current project that is under development and that will go on board the International Space Station. So, as you know, I'm an aerospace engineer and pianist. The art part is important, very important for dissemination, and I will talk a bit more also about it, and explain you why. So, now, also thanks to the work of Joseph, this year Malta managed to upgrade its status in the framework of the ESA plan for European cooperating states. This means that now we can have access in competitive funds, of course, to much bigger funds than before, and hopefully in 4 years minimum, Malta can become a associate member, so not a full member, but the stage before, which would be already a great achievement. Now, quick overview, 2022, everything started thanks to Joseph, where I didn't take part as aerospace engineer, but as a musician. So, for public dissemination, with Joseph, we sent one of my compositions, Maleth, from the same name of the mission, which Maleth is a Phoenician name, old Phoenician name of Malta that can be translated as safe harbor. And I like this meaning because it can be referred like Malta is in the middle of the Mediterranean and has been a safe harbor for centuries, so this beautiful island. Same thing, we can think about planet Earth being a safe harbor for the astronauts that will venture more and more into the expanse. This led to Maleth 3, where also MCAST became involved as official partner. And Joseph mentioned the qualification tests. Now I'm using that experience to build up for what it is ASTROBEAT, because ASTROBEAT is not a bioscience experiment, but many, many things are in common in the development of a space mission like this. So, talking about outreach, this led also to put together which was of experience, and what is in this book was also presented at different conferences, huge events that are including no more only the more technical part, but also the part related to space art. There is the biggest event in the world for aerospace, International Astronautical Congress. In Milano in October are expected around 10,000 attendees, so people in the field. And they have a full symposium for each day of the conference dedicated to space art and space outreach. So it's something big to keep an eye on for the future. Now, here you see an artistic rendering of ASTROBEAT before showing you the real photos. Before going to talk in detail what do I mean with a cold welding adhesion for spacecraft repairing, in a couple of slides I give a quick overview of the issue. So basically, as you probably know, since the first launch with the Sputnik, our, above all the low Earth orbit, the orbit around our planet, started to become more and more polluted with what we call space junk or space debris. So in orbit we have micrometeoroids that are of natural origin and space debris due to human activity. Now, it's true that in space there is a lot of space, but here we are talking about hundreds of millions of fragments that are building up during the years, which is the fact that the access to space is becoming more and more critical and dangerous, above all if you have a manned mission, so with astronauts. Plus, is putting at risk the missions that are already there, that if you have a catastrophic failure, can lead to the creation of more debris. So it's a serious problem that can affect our daily life. So, why are dangerous space debris? Just to give you an idea, you see that small sphere is 1.5 grams of aluminum, which is the most common material in space. At the range of speeds that you find in orbits that are of the order of kilometers per second, you have a huge kinetic energy associated with these impacts. So one little sphere like that, you can compare the energy delivered in an impact to a crash of a medium-sized car or the energy of a hand grenade. So is something really disruptive. Imagine a spacecraft, above all a spacecraft that has astronauts inside. So here is a laboratory test showing an hypervelocity impact where you have an aluminum plate, which is a classic simple shield for spacecraft, impacted at a high velocity, and you see the creation of a huge debris cloud that are further debris that can impact other structures, plus the generation of a hole. So the whole thought about also be environmental friendly, as correctly Joseph said, is okay, nowadays, when something like this happens, most of the time you have to scrap the mission. What if, above all for human missions, we can repair that damage? So, here enters in the game ASTROBEAT, which is a project that is developing the prototype of an experiment to be tested on board the International Space Station, where there will be the testing of a phenomenon called cold welding adhesion, and I will go a bit more in detail about this. Before going more in detail, I wanted to highlight that this project is mainly funded by MCST, Malta Council for Science and Technology. As MCAST, the proposal that I submitted was awarded with the funds to develop this project. Plus, is an international collaboration that sees Southeast Technological University that is in Dublin, and plus more recently joined New York University Abu Dhabi, in particular the Center for Astrophysics and Space Service led by Professor Andrea Macciò. So it's an international collaboration, and on a practical point of view, the company providing the service is Nanorax, that now is called Voyager Space, that is based in Houston. And you have that basically my day is I'm working here with a Malta time zone, Dublin that luckily is only 1 hour behind, Dubai 3 hours of difference, Houston -8 hours. So it's a quite a wide day in the management. So here is the team, so led by myself and Dr. Mark Wiley, which is in Dublin with Southeast Technological University. Mark Spiteri, that you know since he's a lecturer here and is a researcher about the project. Luke Farson, which is a structural engineer that is supporting the mechanical design part. Steve Boajar, electronic engineer that is developing the software of electronic, and Tiba Shafek, which is a master's student at Southeast Technological University. Cold welding adhesion. In space, cold welding adhesion is a phenomenon that usually has always been seen as the devil. Why? Because basically in space, thanks to the particular conditions of microgravity and vacuum, metals, above all of similar type, when in contact, get stuck, basically creating this so-called cold welding adhesion that we can get also here on Earth, but we need a high amount of forces. In space, the forces needed are very small in comparison. So how humans discovered this phenomenon? The first example was in 1965 with one of the first missions from US, Gemini 4 mission, that saw the first EVA, extravehicular activity. So the astronaut of Gemini 4 went out, did the first historical spacewalk for the US. The colleague was waiting inside the capsule. When he had to go back, what happened? The hatch was not closing, was stuck. So they said, oops, we have a problem, serious problem, because you can't re-enter with that spacecraft with a capsule with a hatch open, of course, passing through the atmosphere. So luckily, with applying a lot of strength, the adhesion was still not complete, they managed to close the hatch. So basically, they came back safely to Earth. There was also another mission in the 70s, a $1 billion mission, Galileo, that when it was arriving near Jupiter to study Jupiter, had an antenna that was umbrella-shaped because, of course, in a rocket you can't put something super wide. So it was compacted. When this umbrella shape, I'm simplifying a lot, was going to open, didn't happen, only partially open. Why? Due also here to cold welding adhesion. So that was a serious problem for something million of kilometers far from Earth. So now what we did, and this is why also we were successful in our proposal, we changed the point of view. And with Mark Wiley, we started in reality working on it nearly 3 years ago. We said, what if we use this to our own advantage? So there is an episode of Black Mirror where the same actor that did Breaking Bad, Jesse Pinkman, in this episode is with another astronaut on a space station of a certain type, and there is a small emergency, and he goes outside to do welding. In the episode is a normal welding. But here we are passing from science fiction to actual science. So, as I was mentioning, with Mark Wiley, we started in reality 3 years ago. We started developing a first prototype last year, and Max Piteri went to Dublin to do the first test, so we started really from scratch. This also helped to win the proposal, and we arrived to what I will show you more in detail, to what is ASTROBEAT. So it's a 1-unit cube, so a little bit smaller than this, so they are both a very small experiment, where inside, basically there are 4 chambers that will test the application of different patches, we call, to test the cold welding adhesion to repair a hole. Here we didn't take real holes from a space debris impact. They are calibrated holes, everything is measured. So we want to verify that with the forces we are applying, we are actually able to fix this damage. So it is a 1-unit experiment. Our mass budget is very small, 600 grams, because in total is 1 kilo of a cube. We have a stepper motor, a mechanism that I will describe, an ohmmeter to read the measurement, because imagine you have 2 pieces of metal going in contact. You can measure the resistance. We have also has a Raspberry Pi and a camera to monitor the movement. So the core is represented by the 4 chambers. So one chamber basically is structured here like in the image, and the most important part is the one with the blue rectangle, where you have a plunger that is actuated by a spring. And you can see here one sample in aluminum, and, 2 samples, male and female, and 1 couple in copper, because we want to test both material. Why copper? Not because it is widely used in aerospace, but because for cold welding, there is at least some literature, and the properties are very well known. So we wanted to compare. And we will have 2 couples in aluminum and 2 couples in copper. And here you see the 4 chambers separately. I didn't bring here the cube today because in 10 days I will be in Houston at NanoRax and NASA Johnson Space Center for the functional test, and exactly in these days the electronic is undergoing, let's say, surgical operation in the sense of the final soldering of the flight configuration for the contact. So wouldn't have been safe to take it out from the lab and having it going around. This will happen after the experiment comes back to Earth. So here is a photo while we were doing the test. You see also intermediate phases of the development of a cube with also some 3D printed parts to do preliminary tests. And here is a video rendering done by Skyup Academy, which is a academy in Italy that does high-level 3D projects for Hollywood movies, video games, and train people to do that. So they are one of the best in Italy and one of the best in the world. And they helped us to provide a artistic rendering of the experiment. Here, unfortunately, is a bit glittering the video, where you can see the exploratory view and the functioning of the experiment. So here you see in the top part there is the electronic. Here you have the plungers with the samples that I mentioned. On the back there is the camera, and here you see the functioning, where the stepper motor actuates those cogs, and the springs deliver a force to the our samples, where we want to be able to make the cold welding adhesion. Now, this is the 3D rendering, but we have also a video with nearly the finalized version of the experiment. Now, this is the flight model that soon will be tested in Houston, where you see exactly the same thing, but of course everything is assembled here. So this is a view of experiment, and here you will see on top 1 chamber actuated, and on the side the other 2. Everything will be inside the cube, and on SpaceX rocket we will reach the International Space Station. So the experiment is targeted to be launched on the 17th of September, so very soon in reality. Working on this project is highly demanding, how Joseph correctly highlighted. There are a lot of requirements, a lot of deadlines that you have to respect. Otherwise, to put it in simple terms, NASA simply says you don't fly, end of the story. So simple as that. There is a different way of thinking in the space sector, and is very, very challenging, and luckily also very, very fascinating. So the experiment will stay 1 month on board the International Space Station. We will do in the first part the scientific part, so we will test our chambers. And after, there will be also the part related to space art and the dissemination. And here, now I will describe a bit. So, NYU Abu Dhabi is a part of New York University with a headquarters, of course, in New York. They are the biggest private university in the world. And I went there in Abu Dhabi. I was invited for a conference and also for an activity that now I will show. They have incredible facilities, and also they, thanks to Professor Andrea Macciò, they contributed to the project. Now is a first step for them to basically having the possibility of analyzing the data of experiment, and is a very first important step for a future collaboration in building up for bigger projects. So I also presented ASTROBEAT at the Visible Certainty Conference with very high level ranking people in the field, so it was a great opportunity. Plus, we are leveling up the part related to space art in two ways. One, in this case, yes, my music is going back to the International Space Station to be streamed from space to Earth. But in this case, the project, in particular with the composition Moonseed, got the interest of two top-level artists. So Tina Guo, cellist, and Steve Mazzaro, producer. In the music business, their name is huge, and they are collaborating since several years with a name that for sure you know, which is Hans Zimmer. So Dune, Interstellar, Inception, so we are talking about the best you can find in the world. And this, their support from the point of view of dissemination is amazing, because just think to the type of public you can reach disseminating these activities and what is literal space art, because it is in space. So besides this, there is the part related to also involvement of students. So when I was at NYU Abu Dhabi, in collaboration with Professor Carlos Guedes, which is a composer, we organized a music contest for all the students of NYU. And two compositions were selected, having the commission also Tina Guo and Steve Mazzaro, were selected to fly with ASTROBEAT and being streamed as well. Plus, there will be also a composition of Professor Carlo Guedes representing NYU. Moreover, I recorded there the music that will be in space. And basically there they have also, they teach also recording techniques and music production. So in collaboration with Professor Matteo Marciano and his team of Gazzini Records, there was also the full production of another composition of My Black Sun that is fully produced by NYU. So this was an experience for the students like you to be exposed to something different, something new, and something that for me and Joseph is now the present, and for you is the very near future. Plus, this of course helped hugely with the dissemination. So, undergoing the safety review with NASA in collaboration with NanoRacks. In September, hoping that there are no storms, no delays, the experiment will be launched. We'll stay 1 month, we'll come back to Earth. The experiment first will come back to Malta. Still, we will not put it for display because the samples that needs to be untouched will go to Dublin, where they have a facility with cutting-edge technology for metallurgical analysis. They will analyze the sample at a microscopic level to see the molecular bonding and the quality of this cold welding adhesion. And of course, when the experiment is in space, we will have preliminary data from the ohm-meter reader and the camera. After that, everything will be back again in Malta, and there will be an event where everyone will be able to see actually the cube. So that's all I have for today. Now, thank you for your attention. I hope that you found interesting both the projects. And now, Joseph, I guess we can have 10-15 minutes for a bit of a discussion, and we can also have your colleagues involved. Okay. Thank you.
Good stuff.